Today we will talk about the ways we interact with operating systems. Also, we will discuss how some principles from functional programming can be applied in operating systems and package managers. After that, I will show you how we can make the configuration for operating system very declarative, and we'll do a demo. And maybe we will lightly touch the management of per project development environments. And also, I will give a lightweight comparison of Nix and Guix package managers and related operating systems, NixOS and Guix systems. Uh, Also, the few basic terms that I would like to discuss before we start. The operating system itself, it's something that based on file system hierarchy standard, like the structure of directories which you see in many Unix systems. Bootloader, kernel, utilities like GNU, binutils, or something like that, which helps you to interact with the kernel, virtual file systems, services, etc. Everything else we consider like an operating system. And home environment is what you basically have in your home folder. It's .files. Also, it packages that actually can be installed without root privileges. I will explain later how it can be done. And services, which not system-wide services, but your personal services. Your personal cron, tab, some pipewire, and maybe other stuff that you want to have. Maybe BitTorrent client or server, and so on. Also, the development environment, it's basically, there's a concept in Python language called virtual env, which allows you to install the different version of Python interpreter, different from the system one, and packages for Python. But in our case, the development environment will be a more generic term, which can include some additional tools like linters or maybe utility stocks as databases, and maybe some tools for spinning up services that you need, for example, a database. And let's see how we usually interact with operating system. In our case, we will imagine that we have a new laptop and want to migrate to it, so we need to set up our operating system. Basically, we do a lot of commands, and between them, we do some editing of configurations or copying or something like that. Let's let's discuss just a few applications. We need a window manager to show everything that we work with. Also, we need a terminal to type some commands and interact with the kernel and other stuff in our system. We need an editor to actually edit configuration files, to edit the code, and so on. And each step requires not only installation of those programs, but also configuration. So we go to the related folder and edit config files. And for example, after we installed a terminal, we need to go back to window manager configuration and add key binding for the terminal in window manager config. After we installed fonts, we need to go to all the configurations of all previous applications we installed and edit them and set a font to the specific value. This is the example which demonstrates the very imperative approach for working with operating systems. And actually, there are few problems with it. For example, we can't change the order of the steps. If I will take those steps and will try to perform them before installation of window manager, I will fail on the third step, which requires to edit window manager configuration and to add a key binding for the terminal. So it's very order dependent. Also, every time we touch any configuration file in our system, it doesn't matter if it is a configuration file in home environment or in operating system in etc directory, we edit the state. And as we already know from some experience from functional programming, it's not very good when the state is spread all over your software system. And we try to minimize and to make the state very explicit and to be in one place. and keep the rest very pure in terms of functional programming. And is there other way to do the similar stuff to achieve the same result? We can utilize some properties of configuration tooling and to make the same installation to be declarative. But before we discuss the actual implementation, I will show you 3 ways to manage the system. First one is to have some specification in your head or in a text file and try to make your system to conform this specification. And in reality, your target is here on the picture, but the actual result will be very diverse from what you really like. And over the time, this difference will only increase. And it's really hard to reason about such system because every time you did some change, it will affect your next step you will perform later. And in the time scale of few years, it's almost impossible to maintain the system and keep it with your specification that you want to achieve. There is another way to use some automated tooling which tries to hide this imperative complexity and try to provide you with a declarative interface where you write your specification in some domain-specific language, and the tool itself performs those sequences of actions and try to move your system from the current state to your target specification. It's a little better and you get a result closer to your specification. But it's still not ideal because depending on the actions which was performed earlier, the result may different from your target specification. And there is a last way. When you actually have a specification, build a complete operating system or home environment from the specification and install this operating system to your computer or to the remote server or somewhere else. And it looks good, but it sounds very slow because every build of operating system will take a lot of time and the deployment will also take a lot of time and so on. But of course, we won't be using a naive approach for implementation. We will use something smarter. And also, if you have any questions during the talk, please type them in the chat. I will be reading them on my second screen. Maybe I will answer them just during the presentation, or will be answering them later. So we discussed the imperative approach for interacting with operating system and also discussed how we can do it declaratively. Let's go back to functional programming and discuss some concepts from it and how they can be applied. In functional programming, we need only one thing, the functions, the pure functions in mathematical sense, and everything else should work fine. Actually, we can even express some values like numbers with church numerals and so on. But to be more pragmatic, we will have a separate entity, a value which could be implemented without functions for the performance reasons and so on. And we have immutable values and pure functions. And now we can express any computations that we want. And now we have a pure functional language and we are happy. But not yet, because we cannot see the result of this computation if we have absolutely pure functional language. For that, we need something to share the result with us. For example, to print it to our terminal or to make a file on our file system or to access network and so on. So we need some mutable objects where we can save our state. And there's a catch here. The state is quite dangerous because if we use the state all over our software system, it becomes less functional. And that means that this part which affected by state will be harder to test because to replicate the test environment, we will need to replicate all the state which connected with this function. And also it will be hard to reason about this part of the system because it touches a lot of things, and it's really hard to develop and maintain such projects. So there is one very important pattern that many developers follow, that you try to minimize your state and to make it as explicit as possible. So you place it ideally in one or few very explicit places, and everything else you try to make as pure as possible. I hope everyone agrees with this idea, but if not, let me know and we will discuss it later. Now let's talk how it relates with operating systems. As I already mentioned, when you touch any configuration file, you edit it. Doesn't matter in operating system, in etc directory, in your .config directory, in your home folder, you change the state of operating system. And the whole software system that you have on your machine is affected by this change. And every next step that you perform can have a different result from what it was before you change this configuration file. The installation of the package. Basically, the package in basic distribution is a archive which contains binaries, libraries that you extract to your root folder, and all files goes to the /lib or /user directories and overwrites the files that already exist. And every next step, like updating packages, changing the configuration, restarting services, will be affected by this installation or update of the packages. Also, external repositories. The system always, not always, often rely on some external repository. And when you do update today, it can be very different from what you will get 1 week later. So the state not only on your computer, but also on remote servers. Also, the time when the binary was built and the package was built also affects the end result because it changes hash sums and so on. Also, there's quite a lot of things that can affect the state of your system. But I think those examples are enough. Can we do it differently? Actually, yes. And there's at least two purely functional package managers, Nix and GNU Guix. Currently, I work and contribute on GNU Guix package manager, but I also have experience with Nix. And the principles, the ideas behind them are very similar. Instead of having a package to be an archive that you extract in your system and change the state of your system, you have a function, a pure function in terms of functional programming, which accepts as inputs all the dependencies like compiler, libraries, additional packages, tooling, and so on, and produce the result to the directory, which resides somewhere in the separate directory called store. Everything happens in isolated environment. So you don't have access to the network. You don't have access to the time, to external file systems, and so on. So it's almost a pure function, and the result will be the same for the same inputs. But of course, it won't be useful if you couldn't place the result to your file system hierarchy. For that, we have another entity called operating system. And here it will be very similar to the package. It's also a pure function which accepts two arguments, the configuration and list of packages. And after that, it produces a directory which contains all the necessary packages, all the necessary configuration for those packages, all necessary configuration for services, bootloader, and so on. And also, it provides one script called activation script, which allows you to do only mutable thing, is to create a new generation of operating system. So every time you update a config or you update a package or a list of packages, you get a new version of operating system, which appears in your store directory. And after that, you can switch to this new generation. Switch is atomic operation, like the same as atoms in Clojure. Uh, you just do a symlink to your new operating system, and every files from this directory goes to your root file system, and that's it. Um, Now we also have a home environments which works the same way, but not for the whole operating system, but only for a home directory. You can install packages with it, you can create services, you can create configuration for your user space programs. And having everything to be a pure function, now you can reason about system much easier. And only state that you have is a var directory, which contains maybe the files for the database or some persistent connection for the network daemon. And you have a state in your home directory. It seems like a good application of principles of functional programming in operating system world. And in my opinion, it makes the work that you perform with your operating system much easier. And let's see how we can build a declarative configuration on top of those things that I described earlier. Actually, before that, let me show the example of package definition to make it maybe clearer how it looks like. We have some meta information about the package, its version name, the source code. It also has a hash, so we sure that we get the same source code every time this package definition evaluated. After that, we have a build system. Basically, it's just a list of steps like /configure, make install, or maybe some other steps for different build systems. And arguments which can maybe modify phases of this configuration of this build system or provide some additional stuff. And list of inputs or dependencies, like the packages that will be available or headers that we need for compilation of this project. Also later, I will show the build process and will show what store directory looks like and why the implementation of these pure functions are quite smart and doesn't require a lot of space and doesn't require a lot of stuff to rebuild the whole operating system between few generations. Okay, let's try to build a declarative approach on top of the ideas we discussed earlier. We want to replicate the similar setup that we had on the first slide about window manager, terminal, editor, and font. But instead of writing the steps that we need to perform to achieve the results, we will create a manifest which says what we really want. And after that, the tooling will try to make it happen. And here you see the declaration, which says that we have a font monospace, EOSIF font, we have Alacrity terminal, we have Sway window manager, and we have Emacs text editor. Very good, but does it work? Actually, you see that I already have a window manager, Emacs, and editor. And also, to be sure, I will show you that I also have a terminal, which is Alacrity. And it's fully functional terminal. Good. In addition to that, I will show that I have a config for this terminal. Somewhere in .config directory, I have a configuration for the terminal. I demonstrate the example on my home environment, but the same principles applies to the operating system. So it's just for simplicity reasons. Okay, now let's remove our terminal from the configuration and what happens when we want to achieve the same result here. We installed terminal, edited a terminal configuration, added a key binding to VM config, and now we want to remove terminal somewhere here. So we need to roll back all those changes that happened before. There was 3 changes, but you can see that in the real system it will be much more. And actually, we need to remember that we added a key binding to window manager configuration. So we will remove binary itself, package itself, configuration for it, and we need to edit a window manager configuration and to remove a key binding for the terminal. And also the point I didn't mention here, that with the growth of application, you get almost exponential growth of the command because every new command can be affected by previous actions, and you will need to perform another additional actions. For example, for the font, you need to do 3 actions if you have 3 application here. Not always the case, but in some cases it's important. Okay, going back to our configuration. I removed a feature alacrity from my configuration, and I had to start the build process, not to make you wait, but it will take just a few seconds. Good. It seems that system reconfigured, and now let's try again. Our Emacs is here. Let's see if we have a configuration for alacrity. Whoop, we don't have a configuration for alacrity anymore. It was removed. Okay, let's try to launch the terminal using the same key binding. And now the different terminal appears. It's a default terminal for the Sway window manager and not the Alacrity one. It's called Foot, and it's available on our system, but Alacrity is not available anymore. So we removed a feature from our manifest, and now the terminal gone, and also all related configuration also gone. If you take a look at configuration of Sway window manager, we see that the term variable is equal to foot right now. But let's return back our feature alacrity. And also for the demo purpose, we will change the font also. And now reconfigure my system again. Oops. I see that there's some comments in the chat. Oh, Ariadne, thank you. Thank you for a humble comment. Okay, we reconfigured our system again. And now let's take a look what we get. We open Emacs text editor, and now it has a different font. Okay, it's kind of expected. And let's take a Sway configuration. Let's take a look at Sway configuration. And now we see that the file which placed in the same path in .config/sway/config have a different content, and the term variable is equal to alacrity now. And also, if I use the same hotkey, I get alacrity again, and it also has the font changed. Now we see that this declarative approach works quite good. And every time I want to reason about the system, I just look at this manifest and see what I will get. Actually, every time this code get evaluated, I get a new complete home environment, and this complete home environment get installed in my system. But it, of course, done in efficient way. So every time I do a small change, it doesn't recompile everything from scratch. It's very similar to what we have in Clojure. We have, for example, vectors or maps that looks like every time we edit them, we create a new value. But in reality, the persistent data structure under the hood prevents unnecessary copies, because if you have a very big vector and it represented as a tree, and you edit only last element, this last element can be created in the memory and only just a few links updated, so you will get two trees representing two versions of the vector, which shares almost all the elements. So very similar approach is applied here in Nix and Guix package managers. So you never do unnecessary recompilation. If you build the package which has some inputs, and you build this package again, you will get the same result. So there is no need to build this package twice. Also, there is no need to copy this package somewhere, because you can use the same result in many different version of operating system or home environments. So you just do a link to this package instead of building it. And if in case some changes to package happens, like you updated your compiler or something else, the new version of the package will appear, and you will need to build it and to reference it from your operating system. So let's take a look at how a home environment looks like. For this, I will visit, let me go to Guix Home directory, and it basically has a few things here. First one is activation script, which actually do all those side effects like copying the results to your home folder and symlinking and all the stuff. Channels and configuration is basically the configuration which we used to produce this home environment. Files is a directory which contains all the configurations. For example, .config directory, which contains a configuration for Alacrity and Sway and so on. And as you can see, all those files is not an actual file, it's just a symlink to the GNU store. So all heavy lifting is done by build daemon, and all the results resides in one directory. Here I only do symbolic links to the files in store directory. Very similar to what we have in our data structures when we implement them using some persistent data structures. Okay, what else do we have here? We have a few more scripts, which maybe not very important for us, but also we have a profile folder, which looks very similar to what we have in our file system hierarchy standard. We have /bin, /etc, /include, /lib, and other directories, which contains all necessary files. But in most cases, those files don't get in our root folder, and even symlinks don't go here, because we always or almost always can configure our environment variables to change, for example, the directory where we look for executables. For example, we have a path variable which contains not only /bin directory, but also /home, /username, /Guix Home, /profile, /bin directory. So every package installed in this directory will be available in user shell and all other user applications. And as you can see here, all applications that are necessary only for my user and not necessary system-wide are installed in my home profile, not system-wide. And this is the way how you can install packages in your operating system without root privileges. You have a separate GNU store folder. You build the package in this GNU store folder. And after that, you just point to the folder with binaries using your path environment variable. And it won't break anyone setups on the same machine. It won't break operating system because every file in GNU store folder doesn't conflict with other packages because every result of package build has a hash prefix. And if you change the compiler version or some dependencies, the change the hash changes, so you will get a new version of this package, and the previous version won't be affected. So if two users have the same, absolutely the same package in their profile, they will use actually the same folder in GNU store. But if they want different packages or different version of the packages, they will be installed in parallel, and one version will be available for one user and the another for another one. Okay. Uh, what we got? We got a declarative way to describe our configuration for home environment, the same way we can do for our operating system. And also we got a nice fig wheel-like experience, like we do updates on the fly. We have all the stateful stuff the same as it was before, but updated all underlying configuration. Of course, it doesn't work as well as Figwheel because not all application supports this kind of live reloading and so on, but uh, we can say it kind of similar to what we get with this nice interactive experience from Figwheel. Okay, another thing that we got, every time I do the reconfiguration of the system, I create a new generation of home environment. Actually, it is the only side effect which happens during this reconfiguration phase. And we can see the list of generations. Oh, you can see that I have quite a lot of them. And you can just go to this folder and to see that I have a lot of home environment generations, and every time I break something. For example, I installed the package that doesn't work. I screwed up my configuration file for some application and it stopped work. I can easily roll back to the previous generation. Let me demonstrate it. Guix Home rollback. And now you can see that the font of my status bar changed. And also if I open a new desktop, you will see that the font of editor also changed and Alacrity terminal disappeared. Very nice. In reality, I use the much complex config that the one you see here. Actually, it's my actual configuration, but I narrowed it to one screen. But in reality, it's a little bigger. It contains all the stuff related to my system, to Emacs configuration, to my, for example, mail client and utility for synchronizing mailing list and so on. Okay, that's it. That's it about home environments and operating systems. I think I have 10 more minutes for the talk. We can lightly touch on development environments. But before that, let me read the comments that we have in the chat. The Joel asks if the operating system I'm showing is a Guix. Yes, it's a Guix system, and the tool that I use to manage the Guix system called RDE, my own project for managing Guix System and Guix Home. Just a nice wrapper with good defaults, I would say. The nice question from Ivan Kanakarakis. What happens if you edit a config directly? You can't edit a configuration directly because if I will try, if I will try to open a sway configuration, for example, and we'll try to type something, you will see that buffer is read-only, but it's not only the buffer, but also the actual file system. GNU Store is read-only for everyone except the build daemon. So you can't edit the configuration. What you can actually do, you can remove a symlink and place your actual file instead of symlink. But next time you will call the activation script, it will clean up all the stuff and will remove all stale config files and will put them in backup directory. And instead of the file, it will put a symlink to the GNU store again. Another good question from Ivan. He asks if I break a Guix itself, is there a way to roll back or reset it? Yes, but to clarify, we have a Guix like an actual binary which we use to execute commands, and we have a Guix like Guix system, and both answers is yes. You have not only your personal binary. Let me show it. In your home, let me open the shell and show the path and which Guix. Okay, let me open a real shell, which Guix. Every user has its own version of Guix, so it can manipulate this version. For example, using Guix pool, he will get the latest version of Guix, and also he can use Guix pool minus rollback to get a previous version of the Guix utility. And also he can use a system-wide Guix, which we know that works. And when we're talking about operating system, in grab bootloader, you will see all the generation of operating systems you created. So if you break your operating system, you can reboot and pick the appropriate working version from your grab bootloader and boot from the working version. No Vim configuration. Yep, I don't use Vim anymore for almost 5 years, I think. And Joel asks, what would you recommend for someone interested learning more but is not familiar with the ideas and the concepts of Guix yet? You can read the manual, it explains a lot. Also, you can find other resources like articles or videos in the internet. Also, I do streams from time to time on Guix, but maybe I didn't explain very basics, or maybe explained. You can watch the recordings of my streams if you want. Okay. Thank you everyone for the questions. Let's go back to the presentation and talk a little more about managing development environments. In Python, we have a virtual env, which allows to create a folder which contains a specific version of Python interpreter and all packages necessary for the project. Let's imagine that we can do the same, but for any language and for multiple languages. And also it not only restricted with Python packages, but it can also contain, for example, utility to connect to your database or do some other stuff like spell checking or linters or something else that you need for your project. And it's possible with package managers like Guix and Nix. We already discussed that we have environment variables that we can set to create an environment which contains only binaries we're interested in. Let me reconfigure my system again and bring back as it was before. Or not. Actually, I can just launch a terminal here. What we can do, we can use a utility called Guix Shell. It's a subcommand of Guix, which allows to create an environment where some packages is available. For example, here in .config/sway, I don't have make utility. But if you take a look at the compilation command in my project, I have make -key k command here. And when I execute it, it actually executes a make and do some actions. How it happens? When I enter the project folder, a new environment spawned inside it. So some environment variables got set to some values. And let me demonstrate the example. I don't have htop utility, but if I type Guix shell htop, now when I type htop, it actually executes it. And to make it clear how it happens, I will add a flag which shows which environment variables will be set when I execute Guix shell command. And for example, if I add man pages package, or not man pages, info reader, or mandb probably. Yep, mandb package. It will also set a man pass. So inside our shell, let me spawn the shell again. When you see this blue additional arrow, that means that I'm in the nested shell. And now if I type man htop, it shows the documentation for htop. But if I spawn a basic shell with only htop, it will say that there is no manual entry for htop. So not only the binaries become available, but also documentation and all other stuff that we can set up with our environment variables. And the same works for the project, but with a little more automated way. I have a special configuration file inside project directory, which says what packages I need to be present in my project. And when I enter the directory in the shell or in Emacs, I got those environment variables set to the proper values. But not only those environment variables set to the proper values, but also the environment itself, like packages got built and placed in GNU store. And only after that, those environment variables got their values. And now I can issue the commands that is not available in my system, but available in my project directory. It is the very brief overview how we can manage our project environment. But important thing here that I didn't mention yet, we have a pure function, which depends only on its inputs. That means that we can get a very reproducible result. For that, we need only version of the channel. Channel is basically a collection of the packages, and version of the channel is just a git commit, which corresponds to some version of this channel. So if we have a version of the channel and the list of packages that we need, we always can reproduce the development environment, and every developer who accesses this project and who has this file can get the same, absolutely the same binaries on his machine. So it won't be different version of Postgres SQL utility or different version of the libraries on different machines. And also later we can move this development environment to our production. For example, we just remove linters and some development time stuff, and the rest we'll put on production server, and it works absolutely the same as it works on our development machine. There is some questions that I already discussed in my stream, but if you will be interested in it, I can answer them later. The two last features that I will highlight. First of all, we can create not only environment, temporary environment for working on the project, but we also can build a container from from this declaration. For example, Docker container or tar archive, which are locatable and you can use on different machine, and so on. And the very neat property of this container, it's reproducible, because, for example, Docker containers built with Docker file are not reproducible, because every time you run a Docker build command, the result of the evaluation will depend on the content of Docker file, and not only the content of Docker file, but also on external services. For example, if your Docker file has apt-update command, if you run it today and run it 1 week later, it will get the different list of the packages which will be installed in your Docker container. But with such kind of shell with frozen dependencies, you can reproduce the exact the same container if you really want. So even building a Docker container is better with such tooling. And after that, you can easily deploy what you have. For example, your operating system configuration, you have it on your local machine. You can also build it and have it in your store. But later, you can use a Guix deploy utility and copy all the content of this directory to remote store and instantiate it using activation script on remote host. It happens, of course, automatically under the hood in invocation of Guix deploy. Yep, I think that's it about managing development environments. I have one slide about Nix and Guix similarities and differences, but let's discuss it later if someone interested. And the conclusion. We can basically build operating systems and home environments in reproducible way. We can apply patterns from functional programming to make the management of such operating system and home environment very handy and actually manageable. We got rollback and switch generations, which works great and saves us from losing our mind when we break our system. And we can build containers properly. We also can manage per project development environments with such package managers. And we can deploy to remote machines what we built locally. And it's very reproducible. So thank you everyone for your attention. There's my contacts. You can find me on the network by this nickname and can drop me a line if you want. And now let's discuss something.